Okay, good morning, everyone. My test, so sound clear? Please raise your hand. All right, okay, thank you. All right, thanks for joining class this morning. Okay, so for the next coming class, I think maybe will be Thursday afternoon or Friday morning. So later I will inform the group lah. Okay. So why I have this earlier class before the school reopens. Okay, so today I have shared the wins for your Form 5 plannings, right? Okay, so here are some update here, but it's still subject to change. Okay, at first, this one after I checked with the school calendars, the wins. So I noticed that the school have slot in the Ujang formative on the week 9, right? Week 9 they have the Ujang formative, so that will be taken 1 week's time, right? So, but whether they have still remains or not depends the later subject to change. So tomorrow we'll have a school teachers meeting. So I think we'll be get this info by tomorrow. Okay, and according to the calendar, right? So the mid-year exam, as I expected, right? Mid-year exam will be on the week 16 to week 18, right? So the 3 weeks for this mid-year exam, and the surprising is the trials lah. I thought the trial will be on the week 30 lah, at least. This is my expectations. But when after I check the school calendar, they're suggesting that the trial will be before your second term's holiday, before September. So it means that it's a month earlier, 1 month earlier than my planning. Right, so that's one of the main reason why I going to have this earlier class before the school reopen. And I will try to settle our chapter 6 and the chapter 7 with the online PDPR. Right, so I did these two small topics we settle first. Right, because chapter 1 to chapter 5 is a big chapter, so I will conduct in the school lah. So, but if you still cannot finish in the school, I will call for the PDPR lah. So what to do? If you see the calendar, you're going to have a trial by week 24, the earliest one. So maybe it's still subject to change our trial. According to this plan, yeah. So help me to admit if there's someone using the personal email come and join. Okay. So according to this plan, you will start trial by the week 24. And after we minus me exam periods and Ujang formative, so means you only maximum you only have a 20 weeks for study. 20 weeks for study. Right. So 20 weeks for study. Okay, so calculate 20 weeks for study, 20 weeks. Each week, okay, 5 periods times 40 minutes. Right, divided by 60. So you only have 67 hours. 67 hours to cover 96 hours syllabus. So still, as usual, we only use 67% to cover the 65% to cover the 100% syllabus. All right, there is a maximum. That's the maximum. All right, maximum time that we have. So anyway, I think the school confirms already. Science subject will have 5 periods, if I'm not wrong, if there's no change according to the planning. So the Form 5, they will fix to go back at 2, right? Go back at 2. So due to that, we got extra 1 periods. Okay, so extra 1 periods for biophysics, chemistry, and maths. So I'm not sure how they choose. Okay, because 1 week Cocoa time, we cannot have this extra periods. And the Thursday, I think also cannot. So I think they only have 3 extra periods to for this meant 4 subjects, ELT subject. But anyway, for physics, I decreased already. So all the 3 classes will have 5 periods. If that if not any change, so some by tomorrow only know. All right. Okay, so please be get ready lah. Okay, and I will print the module by booklets for you, and that module will be I divided into 2 booklet. So each booklet is odd number chapter 135. Another second book it was chapter 246. So that easier for me to manage. So when finish I changed the strategies already. So once finish chapter 1, so I will ask you to submit and for the checking, and at the same time you still can use a second module for the chapter 2. So at least I have a longer time for the checking periods lah. All right. Okay. So hopefully by the open school you will receive. But anyway, one more thing. Not the 20 weeks. Is I think another weeks, because as same as the last year started, first week school we cannot teach. All right, first week school as a KPM fix is for the fun learning. All right, so I don't know for Form 5, because last year I think Form 5 we carry on the class as usual. They got no such fun learning for the Form 5 as an exam year. So I don't know for this year the open, how is it? Okay, if they still have to be fun learning, cannot be teach, because KPM gives the instructions already, cannot have the teaching during the first week the open school. Okay, so if cannot teach, then I plan to do experiments lah. So maybe if it is like that, then the first week we will enter lab to do experiment for our chapter 1. Okay, so the one, let us see how lah. Okay, so for the module I only have chapter 1 to chapter 6. Right, chapter 7 I didn't do the module. Okay, because chapter 7 I see the content referring to textbook is enough already. All right, so that's why I send you the ebooks, okay, for this chapter 7. And as I told you last year before school holiday, I told you already, try to get your own personal textbook, okay, so that you actually can resell it to the second-hand book to the junior if you want, and then the book is not expensive. All right, so the good to have a own textbook is, if you want to jointing anything, you can just write inside, right? And then the book is not that expensive, okay, compared to last time. Right, so hopefully, if possible, can afford, try to get your own textbook. Okay, and this chapter, okay, is totally new in the syllabus, right? So the latest SPM, which is the last 2 weeks just over the SPM paper, that is not, chapter 2 doesn't have this chapter, paper 2 doesn't have this chapter questions, right? Because this chapter, the question can be asked is very, very limited due to the content that you need to learn. It's very, very limited. So only the first and second year they got question the paper 2, and then the third year, which is SPM 2023, it doesn't have any question in the paper 2. And as I told you before this, okay, so the my prepare SPM will have the wrong questions, or the information is not enough. Then this year, a bit serious. I think you get to know about it from the social medias already. Okay, for the paper, right, is asking to compare, in the essay question, asking to compare the X and Y based on the graph provided. But the graph, it doesn't label X and Y. Student got no idea where is the X, which one is the Y. But the question asks to compare based on the graph given, compare the X and Y. All right. So in the case, all right. So if you they really listen to me, you still have to answer it as normal. You don't need to ask, because when you ask the pengawas, they also cannot help you anything. Okay, there is no errata to make the corrections. Right. Okay, so the question, I do believe the marking is still will be processed according to the answer. So you have to assume that one is X, one is a Y, right? So you based on your assumption in answer. So you may need to write the assumption in your answer. And after that, you just respond according to assumption. All right, so I think the question will be marking in that way. All right, so it means that student A, student B, the answer may be different. Maybe the student A said that X is more than Y, but the student B will say Y more than X. So both can be scored. Right, both can be scored. Okay, depends on their assumption. All right, so I think the marking will be going that way. All right, so no such thing bonus mark. Remember, no such thing bonus mark. Okay, this question I think is still okay. Another question even worse. Another question ask to do the calculations, but the one of the quantity that needs to substitute in the formula, it doesn't provide the value. All right, so it's just like the question asks you to determine the force. Example lah, Actually, the question is chapter 3 from 5 electricity. Okay, so I make example like the question asks you to determine the force. So as you know, force equal to the mass multiplied acceleration, the formula. So the question asking about the force, but in the question itself, it doesn't provide mass. It's only given the acceleration. It doesn't provide mass. Then ask a student looking for the force, something like that. So you have the two unknowns in your formula, then cannot be solved. So that question, I don't know how they're going to mark. Right? Because the student cannot just assume that the quantity is 0 or any number. I don't know. Maybe they will accept the student put any logical number. Just like happens 2 years ago, the first batch of the SPM, when the question paper 2 asked about this quantum physics chapter, the structure question also same. So one of the value importance to substitute the formula, it doesn't provide. So that year, they accept any logical answer based on the student substitute value. So for me, that is a very serious mistake of the SPM paper lah. It's very shame that have that kind of quality of SPM. All right. So what to do? There's a mistake. So every year getting worse. So unless they change the panel, unless they change the SOP to checking the paper, if not, I believe that for your batch coming SPM, they will be still have a mistake of the questions. All right, so just be get ready. All right, mindset to accept that it's a mistake question, and then you try your best based on your understanding of concept, respond the question. Don't leave it blank. Remember, no such thing bonus mark. All right, so that's why it never happened in my exam paper. I give you the bonus mark based on the mistake of the questions, because no matter how, they will still have the student respond answer. They still have the way to marking the paper, the questions. All right. Okay, so there's something to update about SPM, and also the next year the planning for your reopen school. Okay, so now we start our chapter 7. Okay, chapter 7. Okay, because as I mentioned, it's a new chapter for you. All right, so you not really learn in very deep. You learn very surface. It's just basically it's just introductions about the quantum physics. Right? So even in the university when we study the degree for the degree course, undergraduate, this chapter only for the certain specific pure physics course they only was studied. So I really got no idea why that started introduce this in the syllabus. All right. Hopefully, not for a bachelor, because they have a review on the syllabus. So on the 2027, they will have the second review on the syllabus with the new syllabus will be introduced. All right. So I heard that some subject will drop in the PD3. They will change to other subjects, and then some subject syllabus content they will have a little bit adjust. Right, certain thing will be removed, certain thing will remain, or some adjustments also we don't know. Right, so but the one will be on 2027, so nothing to do with you anymore. Right. Okay, so the three chapter basically you see that the second subtopics, three subtopics here, the second and the third subtopics, right? Basically, it's the same thing. Photoelectric effect, photoelectric theory. Right. So why we have the 7.3 Einstein photoelectric theory? Because when we study about the photoelectric effect here, there are certain things unable to be explained. Why is like that? Only that after that, Einstein completes the unsolved problem in the photoelectric effect. So because of this, Einstein was awarded a Nobel Award for this finding. Even most of people know about the Einstein contribution in the physics knowledge is about the formula E equal to mc squared. Where every time when talking about the Einstein, so everyone knows about E equal to mc squared. Okay. But E equal to mc squared, this formula, all right, is not the ones to let the Einstein to awarded the Nobel Award. Okay. But the Einstein get awarded the Nobel Award because of this photoelectric effect theory. Right. So that's why we have to be specific, learn about this one's 7.3. How Einstein completed the unsolved problem in the 7.2. Right. Yeah, so basically these two is we learning the same things lah. Right. Okay. Then the 7.1 quantum theory of light. Okay, why I choose chapter 7 to be start for the PDPR? Okay, because 7.1, okay, or the beginning is actually something that related to what we learn in the chapter 5 wave form 4. All right, so I hope that memory is still fresh for you, right? So anyway, my advice for you is you have to start your cell division from now. Okay, because the mid-year exam I will include all the form 4 syllabus. So here I already told you, right? Mid-year exam. Okay, so in mid-year exam will cover all the form 4 syllabus, chapter 1 to chapter 6. Alright. Okay, and then the Ujang formative is the delivery process on the week 9, Ujang formative. So I may include a certain chapter in the form 4 syllabus as well. So the more possible will be included chapter 5, 6 at least. I think I will cover 3 chapter, so that is another way to force you start do the divisions before the trial, before the SPM. Okay, start from the very early beginning. Okay, so quantum theory of light. Okay, so in the last year, okay, the chapter 5 wave, you already learned about the electromagnetic spectrum, right? Electromagnetic wave. So in that chapter, you learned that electromagnetic spectrum is a continuous spectrum. Continuous spectrum means that from the series of the changings of wavelength and the frequency, so in the certain categories, certain range, okay, we category it as a different, okay, different kind of wave, right? So the different type of wave in the spectrum itself. So we call it as the X-ray, gamma ray, UV, infrared, visible light, microwave, and so on, based on the range of the frequency, also range of the wavelength. But anyway, all these type, we link it together as a continuously spectrum. So we don't say that, oh, radio wave, it must be certain value, certain specific value for the radio wave, certain specific value for microwave, certain specific value for infrared. No, it's a continuously spectrum. So it's a range continue. So we category as a different type of wave here. Okay, so totally have a 7. So as I told you last year, if you still remember, in this part, most importantly, you have to memorize it according into the order, either in order of the increasing of frequency or in the order of the increasing of wavelength. So as long as you know the order, okay, because this is one of the popular questions. So it came out in the letter SPM paper 1. Letter SPM paper 1, it came out, ask the student it gives a certain I think if not they give a visible light, so something like that. And then after ask a longer wavelength than the visible light, shorter wavelength than visible light is what are the type of wave. So in the option, ask the student to choose. All right. So there is one of the question normally they will repeat SPM. Okay. So anyway, this is what you learned before. Okay, this is what you learned before. But when come to the about this quantum theory of light, so we're going to learn something that against this understanding. Because in the quantum theory of light, we don't see that spectrum as a continuously spectrum. So in the quantum theory, it proves that okay, the spectrum is not a continuously spectrum. It has a specific wavelength, specific frequency for the particular type of wave, especially for this example, this receiver light. So from here, you can see that there is the changing from the red color to the blue color, okay, as a continuous spectrum. But when it comes to the quantum theory, we see that the light spectrum is with a particular line spectrum, like this, right? So on top here is a continuously spectrum. But in the quantum theory, we see that as a line spectrum. So it can consider that we packet the light wave into the one specific packet. It's not continuously spectrum like this one. So in the quantum theory, we said that okay, infrared radiation. So it will be just a one special packet. So inside there is a packet of wave. And then this one longer wavelength, so there's a packet of longer wavelength. And then this shorter wavelength, higher frequency, there's a packet of the higher frequency. So it becomes the specific line spectrum. That is what happens on the quantum theory. All right. So this part later we will be further discuss about this. So now there is a beginning introductions here. So and then as given here, all objects emit electromagnetic radiation. All objects emit electromagnetic radiation. So it means that includes humans. Our human body will also emitted electromagnetic radiation. So that's why we can use a thermal scanner or infrared scanner to scan our body temperature, right? So because we emit the electromagnetic radiations, right? So and then the cool object emit the wave with the low frequency, right? So for the hotter object, it will emit the high frequency, such as a visible light and the UV radiation. So as our body, because we already have a heat, we have the temperature, so it will emit one of the spectrum here is the infrared. Okay, because infrared is emitted from any hot objects. If the object become hotter, then it will emit UV, ultraviolet radiation. Right. So that is happens on all the objects lah. Okay. So in that case, that's why asking you to have the human also emit radiation. So as I told you, yes, we emit the radiation, right? So and then just only that, only the receiver light among this spectrum, only the visible light is visible for our human eye. Others is not visible. Okay, we in the human eyes we cannot see infrared, we cannot see microwave, we cannot see X-ray, and so on. Only visible light is visible for us. That's why I call visible light. So there's only 7 colors here. All right. Okay. So okay. Anyway, according into the one of the concept for the object that up to the certain level of temperature can emit the radiation, this kind of object we have the name for it. We call it black body. So this is the first thing you're going to learn. First, black body. What's meant by the black body? Black body is actually is ionized body. Means that physically it not really exists for the moment. It's just ionized bodies only. Right? Idealized body that's which is this body able to absorb all electromagnetic radiations that fall on it. So it means that if there's object, all the kind of the electromagnetic radiation for it will absorb. So by the concept, means that all this radiation, electromagnetic radiation, which include all this, when it fall on the one object, this object just absorb all this radiation. So this kind of object we call it black body. Why they use the term black? Okay, as a concept, when we see the body of object as a blue color, means that this object actually it will absorb all, because our eyes only can see the visible light. Visible light consists of this series of colors. So when we see the object blue color, means that the red colors radiations, right? The green color radiations, and also any other colors are orange, yellow colors, whatever. All this color radiation, this, when you fall on this object will absorb. Only the blue color is deflect. So when blue color deflect into our eyes, so that's why we see the object as a blue color. So this part you learn from the very beginning in your primary school general science, right? So, but when all the radiation have been absorbed, it's not deflected, then there will be no any light, visible light deflected in our eyes. So that's why we call it as a black color. Because when all the radiation deflected, when we combine all these colors of radiation combined, it becomes a white color. So that's why our concept is white color, it will deflect most of the radiations. That's why we see the white color. And the white color is not that easily get hot. It's not get hot faster because it deflects the radiation. It's not absorb radiation, not like the black color absorb the radiation. So that's why the black color will be heat up faster. Okay. And based on this concept, right? So when this body, idealized body absorb all the radiation, we call it black body. That's why we use the term black. Okay. But the reality, what the black color we see as a black color, they still have a diffraction of the radiations, right? But this combination, it makes the diffraction color as a black color. But based on the concept, it should be similar, like absorb all the radiations, right? So that's why we use the term black color. At the same time, a black body also is able to emit thermal radiation depending on its temperature. So it means that the black body is not only able to absorb all the radiation, it also can be emit radiation depending on its temperature. All right. So this kind of objects, okay, we call it black body. All right. So the radiation emitted in the form of continuously spectrum and is unaffected by the nature of the black body surface. So it means that it's not depends on the surface is even or smooth or whatever, so it will cause diffractions, radiation. It's not based on the diffraction. It's talking about the emitting and absorb, right? So it's not about the wave phenomena, that the heat and deflect. It's talking about the body will absorb and the body will emit, right? Emit just like the a star can emit the light. Okay, so here are the example here. Okay, object emitting an electromagnetic such as determined by its temperature known as a black body radiator, right? So this is when the body it can be emit the light. So emit the radiation, we call it the black body radiator. Okay, so example here. Okay, so example A, I don't want to comment later. Look at the example B, example C. So for the heating elements, like in our oven, so the heating element, you see when you heat up, you will see that it will be emit the light, just like the fluorescent bulb. Okay, so the bulb also, when you come out into a certain temperature, so the filament bulb, it will emit the light because of the temperature level. Right, so this is a concept like the black body, example of the black body on the daily life. But it's not the truly black body, it's just a similar example of black body. Because up to a certain temperature, it will emit the light. Okay. And regarding this info gallery here, the example in the ear cavity here, it is saying that it's an example of the black body. this part, I don't know how to comment. It's very hard for me to accept it. Okay, because you see what? The light ray enter the ear cavity will undergo the depleted diffractions. You see, it said that undergo the depleted diffractions on the inner wall of the ear cavity. And at each diffractions, the part of the ray are absorbed by the inner wall of the ear until all the ray are absorbed. Right, so they say this is an example of the black body. Okay, so I try to search on internet for any other sources to support this example, even as a black body example. Unfortunately, that I searched for 2 years already, I don't really get yet any other sources to support this can be the one of the example. Because originally they give example to imagine about the black body concept, right? They given the similar, but it's not using the ear cavity. It's saying that any cavities, right? So with a small opening like this, when the light enter, or maybe not the light, with any radiation. So the most easier, usually we will use a visible light as an example of the spectrum lah. All right. So when the light enter into the disc cavity, so it will deflect the silver time in the disc cavity until that all the radiation have been absorbed. So that is a concept of the black body, because through this, even that we see, even they have a small opening here. When we try to look into it, we are unable to see anything inside. It's a black color. It's a dark color because all the radiation have been absorbed. That is a concept that we call black body. Right. So, but the ear cavity, if we shine the torchlight into the this ear cavity opening, you will still able to see inside, right? That's why I don't know why it can be made as an example. Right. So then I noticed there's also a reference book. It gives an example like this: a two building. There's a two building, so one building working behind here, and then the reference book is saying that you see that the darkens behind here as an example of the black body. I think this concept is wrong, because you see the darken behind here because it's blocking the building, is blocking the sun ray. So what you see behind is because there's no light. It's a shadow blocking by this building at the front. So this is not the concept of the black body. Right? So I think something wrong with the example given in that particular reference book. Alright, so just remember, we're talking about black body is the idealized body that will be absorb all the radiation for it. At the same time, it also able to emit thermal radiation depending on the temperature of the body itself. And the radiation emitted by this black body, right, we call it black body radiation, and the black body now we call it black body radiator. Black body radiator because it can emit radiation on its certain temperature. So means that this heating elements, example, the heating element for the filament bulb here, we also can call it as a black body radiator because it can emit the radiations, right, when the temperature is high. So this is the first thing you have to understand about the black body. So far, okay? Okay, understand about this black body? Yes, please raise your hand. So far, okay. So now we're talking what is another problem in the textbook. You see this diagram A, thermographic image of the car. Is there anyone can tell me what is the problems of this thermographic image? Anyone can tell me what's the problem of this thermographic image of the car? Personally, I disagree with this diagram. This diagram is not the example of the black body. But the concept itself to get this thermographic image is the black body concept. As I told you, all the object, okay, all the object able to able to emit the radiation depends on the temperature, right? So when even this thermography change to the human body, it also can show you the different color like this, right? Also can show different colors like this, right? So that's why it's a concept of the black body. But if you're talking about this graphic itself, display the June colors with the different temperature, display about black body radiations. So the concept is wrong. The idea to get this thermographic image is an example, ideal example of the black body concept is correct. But the display like this is wrong. Do you know why? My advice, my hints for you is look at the temperature here compared to these radiations. Anyone can tell me what's the mistake? Anyone? You may rest you may on your mic, try to share what you understand that's a mistake here. Right, so it's confirmed already the 5 periods for the physics class. Right, so I show you because the PK1 just sent in the timetable. Okay. So maybe you screenshot lah. This one is what class? Why is like that? Not by classes one. Why by day one? Okay. So you screenshot yourself, huh? Right, so this is the 5 benches. Okay. So here is Simon. Right. And by Charles. Right. So as you can see, all go back at 2. Every day go back at 2, except this one's a Tuesday time, or for those attend the Bahasa Cina class, Bahasa Tamil, so you have the step back class. So the rest all every day go back at 2. Right? So Tuesday go back early at 1:20. For those not involved the extra class. Oh, no wonder have the 3 additional periods only. That's why Sunday, Monday, and Thursday, because Tuesday cannot have additional periods until 2 o'clock due to the Bahasa Cina, Bahasa Tamil, and the PAFA class. So the one only 3. So now, as you can see, physics got 1 extra periods. Okay, only physics. Bio 2 periods, 2 periods, 4 periods. Only physics. MA not even have. 1, 2, 3, 4. But MA original 5 periods, is it? Or actually, MA before this is 4 periods. Chemistry also 1, 2, 3, 4. Oh, only physics 5 periods. 5 inches. Also only physics 5 periods. When every day, chemistry's got chemistry 2 periods. 2 periods, 5 periods, or 1 single periods here. Chemistry got 1. Bio? Bio 1, 2, 3, 4. So physics extra 1, chemistry extra 1. But I still have another 1 periods. What? MS? I don't know. MS original, how many periods? I don't know. All right. So that is your timetables. All right. So come back to this one. Okay. So from here you see when the highest the temperature, the highest the energy, right? Highest the temperature, highest the energy. This one is a general knowledge or what we learned from the chapter 4, heat. Okay, when the energy object higher, so the temperature will be higher. Okay, and then when we related to the wave spectrum, higher the energy, higher the frequency. So that's why from here you can see the blue color. The blue color actually is on the high frequency side in this visible light here spectrum here. So the red color is the longest wavelength, which is the lowest frequency among the visible light spectrum. And then the blue color is the shortest wavelength, okay, which is the highest frequency. That's why when we arrange the rainbow colors, the on top is the red color, at the bottom is the blue color, because it's follow the wavelength. Okay, the length of the wavelength of the visible light itself. Okay, so according to this means that the red colors one is the lower temperature compared to the blue color. Same as the colors of the flame. When you use the Bunsen burner, in the general science you learn also, the flame with a different color, from the colors of the flame itself, we know what is the temperature of the flame. All right. So the normal red orange color flame, the flame actually up to 300 degrees Celsius. Okay, if you want to have the highest temperature, then you will change the flame with the complete combustions. So which is mixed with the oxygen. So the flame will change as the blue color. So the blue color flame will be the higher temperature than the red color flame, right? So same as given here, you see that this graph of the radiation intensity against the wavelength, right? So for the lower temperature here, 4000 Kelvin, we call it a red star. But for those planet have the highest temperature, example 7000 Kelvin, we call it as a blue star. All right. So, but this graphic, thermographic given here, it label red color, call it for the lower, higher temperature, 24 degrees Celsius. And then blue color, it considered as a low temperature, 6 degrees Celsius. In our normal practice, we always, especially in the arts, we learn the arts, is equal to what the teachers told you in your primary school, right? So we categorize the blue color as a cool colors, red color as a hot color. They want in the arts. But in science, especially our physics, our concept is different. The red color actually is a cool color compared to blue color. Blue color actually the blue color wave, blue color visible light actually is a high temperature. That's why this light game itself is a program setting by the program. Setting by program is then display the color indicates for the high and low temperature. It's the difference with the radiation emitted by the objects. If you want to make it same as our visible light temperature, when the black body radiation emitted by the object according to the temperature, by right, hotter zone, it will emit higher energy radiation. So in the case, it should be fall on the highest blue color radiation zone. So it should be displayed as a blue color. Okay. But because it's a programs according to our common practice in our how to say that, in our colorings. So in our normal practice, we say the blue color is a cool color, so that's why it will be adjusted like this. So it's already programmed by display the different color. But the concept for the object emitted radiation on the different temperature. That's why able to differentiate the color zone. Display like this is a correct concept for the black body. But the way display color with the temperature display like this is not is incorrect with our concept. All right. So that's why I said that this ligand is not a good example for the black body. Just only the way how we get the graphic image is the black body concept. But the display color is not the based on the radiation energy level. Right. So can you understand what I try to let you know? If yes, please raise your hand. Okay. All right. Okay. So now we look at this one. So in our classical theory, as a beginning, I told you already. In our classical theory, we see the spectrum as a continuously spectrum, right? Okay. So, but somehow in the quantum theory, it doesn't show in the way. All right. Okay. So, why it doesn't show in the way? You see here. Okay, this graph. So why we call the 4,000 Kelvin temperature as a red star? Why the highest temperature, the star we call it a blue star? Why it look like blue? Why it look like red? Okay, look at the red colors here. So for this red color star, you look at red color dotted line here. So mostly is the peak, the highest value of the radiation emitted by the star is all fall on the peak is here. All fall on maximum, mostly fall on the red color visible light zone. Right? So that's why we see the star as a red star. Okay. But for the white color like the sun, we say the white star, right? Because the peak value is focused, cover all the spectrum evenly. That's why we see when we all this spectrum, this all spectrum enter our eyes, so we see the mixed color of the spectrum. So we see as a white color because they cover this zone. Okay, but for the radiation emitted by the blue color star with a high temperature of the star itself, the peak value all mostly fall on the blue color zone. That's why we see as a blue star. And then the red radiations here, lower temperature, is not the main radiation will be enter our eye. So for our eye, when the receiver light zone here, so we mostly energy will be on the blue color zone. So that's why we see as a blue star. So if it later on have other temperature even higher than this blue star temperature, we will see as a blue star. Maybe it will go to the different peak here. Maybe that's the highest temperature, it will be fall on the different peak, which is the blue is only cover a part, small part lower energy here. But we still see as a blue star because that is the one visible for us, our human eye. Even that the mostly actually is on the UV radiation, but the UV radiation is invisible with our human eye. So if you check with the device, okay, the device will tell us the peak energy, it will be on the UV. But when we observe the star with our eye, it still look like the blue star because there is the highest energy that on the visible light zone. Okay, visible light. So that's why we see it as a blue star. Sorry, yeah. Okay, so there is regarding about why the star we call blue, red, and the white star, right? So this part okay? If yes, please raise your hand. Okay, so one part that what we have to learn here is that this part also there's a part that prove that it doesn't obey the classical theory. Why? According to classical theory, when we see the spectrum as a continuously spectrum, if we see the spectrum as a continuously spectrum, means that the highest energy, the highest frequency it will goes. So means that in the increasing of frequency is the way of the increasing of energy as well. Okay, but the problem is in this radiation intensity against the wavelength, when approaching the shorter wavelength here, right? So the radiation only have reaching the certain peak value. After that, it will fall. According to classical theory, when there's a continuously spectrum, the graph should be go to the unlimited height of the radiation intensity when you're approaching the shorter wavelength. But the study on the evident result is showing that it only reach a certain peak value. After that, it will fall to the minimum radiation intensity. So this part here is proving that as I told you from the beginning, it's proving the concept that we call it packet of light. So packet of light is the one that we call it photons of light. That is a part here. Okay, so it's given here. Ideas of sparking the quantum theory, right? So light is the electromagnetic wave that is produced from the receiver of an electric charge. All right. So hot object, electron vibrate. Okay, electron vibrate rapidly and randomly in the radiation of produce the light. So as the object become hotter, right? As I told you just now, the vibrations of the electron become more energetic and more light will be emitted. So according to this, it should be the hotter object will be vibrate in the continuous frequency range. So according to classical theory, as I told you, okay, the electrons vibrating at the same frequency should have a same energy content. So vibrations at frequency of the electron has no limit, right? Has no limit because it will be when the shorter the wavelength, higher the frequency, the highest energy will go, right? So it means that it shouldn't have a limit. So the light energy produced vibrations of electron can be this unlimited high value. But the experimental result, so as I told you just now, experimental result like this one, okay, experimental result is involving the black body radiation are inconsistent as a classical theory based on the graph of the radiation just now I told you against the wavelength. So for the black body radiation, the light intensity on the left side, which is a shorter wavelength side, does not continuously increase with the increase of the wave frequency as predicted by the classical theory. So this controversy in the concept of light energy has sparked the theory of quantum physics, because when the scientists study on the evidence result on the star, okay, so when they're receiving the energy level based on their study, it doesn't show that is the spectrum will radiation will be go through the unlimited high when approaching the shorter wavelength. So and then they start to thinking what happens here, right? Why it against the classical theory, which is based on concept shorter the wavelength, the highest the frequency, then the energy will be go and it will be shouldn't have limited, right? It should be go unlimited, but the theory showing that it's not, the evidence showing that's not. So it means it's something against the classical theory. So that's why it start get attracting the scientists or physicists to start on this part. What happened here? So that's why they call that is the spark of the theory of quantum physics. Okay, and then here are the gentlemen that okay about this quantum physics, involved this quantum physics from the classical theory until the quantum theory here. All right. Okay. So all this you may read to know what is their main focus. Example for the Isaac Newton. Isaac Newton actually is see the light. Okay, so describe the light as a single string particles. All right, so that is from the beginning. Isaac Newton, you see the light as a single string of particles. So and then because of that, it is unable to explain a light phenomena, because according to Newton, the light actually just behave like the particles. So when it behave like particles, so it unable to explain about the light diffractions, right? So when this particle, why it enter the different zone, different optical density, for example, the speed of light, glass, and the A, why it will have the different speed, right? So, and because of that, skill is unable to explain about diffraction of light phenomena when you see the light as a particles, right? So after that, come to the Thomas Young. Thomas Young was the one proof that, okay, Young double slit experiment. So he showing the light as a wave. So you see that these two gentlemen here, once Isaac Newton said the light is a particle, assume light is a particle, but Thomas Young show that the light behave like the wave because it proved it with the conductor, the double slit experiment. All right. So, but it's unable to explain the radiation spectrum produced by the black body. So, it's unable to explain why the spectrum is not go to the unlimited energy level or the radiation level. So, it's still not complete yet. Even it proved that the light is a wave, behave like a wave. But and then John Dalton said, okay, is a basic particle that cannot be further divided called atom. So you see, before John Dalton is only say that the smaller particles for the object is atom, and then atom is the smallest one, cannot divide further. But nowadays you know that from the beginning of chemistry you learn inside atom, okay, inside atom consists of the nucleus and the electron. Inside nucleus we have the proton and neutrons. So atom itself also can be divided into very small, okay, elements considered inside the atom. But before that, the John Dalton only said that is the smallest is the atom, right? Okay, some elements will have the same type of atoms, right? So unable to explain the light spectrum produced by an atom, right? Okay, and afterward, the J.J. Thomson discovered the negative charge they call electrons, right? So before that, no one's know about the electron. Okay, so this part is very important because they got the later on when we study about the electric currents, so I will explain about this history, right? So when the people know about electric current, actually before that they didn't know about the electron, right? So the people thought that the current is because of the positive charge flow, but actually after that it proved that this assumption is wrong. After when the J.J. Thomson discovered about the electrons, so this is history happens lah. But the one later on in chapter 3 I will discuss. Okay, so but anyway, findings about the electron is still unable to explain the line spectrum of the light produced by the atom. All right, so all these actually there are many theory related behind deeper, but as I told you from beginning, your syllabus is covered very simple. You just read and know. So far, this history about all these gentlemen, I didn't see there's a question design on the SPN yet. So, but I do believe you still have to read because it may ask in the paper once. It may ask in the paper once. So, example, it will give you options, all the scientists, and what is the importance contributions from them, or the finding from this gentleman. So, example, you may this there. Okay, maybe the correct answer is only for this discovered by electrons, so by the J.J. Thomson's. So then the others, maybe you say that Isaac Newton proved that the wave, the light as a wave, so it's wrong. And then Thomas Young, okay, described the light as a particle, so it's also wrong. And then the J.J. Thomson, okay, finding the electron, correct answer. So it may ask a question like this, just like the Sejala questions. Okay, it may happen because this year I see that the paper 101 questions, it gives the 4 electronic part, right? So the ligand, so asking the which two is the example for the you apply in the automatic switch circuit. So the one you learn in the electronic chapter. So to design the automatic switch circuit, we need a transistor. So actually the ligand, if want to student recognize which one is a transistor. So it's about the device. It's just like show you the ligand, which one, asking that which one is a beaker, which one is a cylinder, which one is a cylinder, something like that. So there's one of question asked in SPM. Okay, it's unexpected they will design a question like this. It's very low level questions, but it's still asked in the paper one. All right, so that's why I think that you have to learn. Or this one, the the Max Planck, okay, is introduce the concept about the quantum, right? So this describe energy means that you see the energy as a packet. So there is starting by the Max Planck. So actually it's a same, it's on the same range of the year. I see 1885, 1879 to 1955. So Max Planck, Albert Einstein, okay, Niels Bohr, and Louis de Broglie. So all these gentlemen actually they are the same period. So that the period actually is the quantum physics year, right? So in the time there is a lot of the new knowledge come up, right? So all the great physicists on the same generations on that time. So we have the one photo. In the photo, there is the greatest physicist in our history, and then in the photo itself, there's only one lady sitting at the mirror, right? Okay, so that one you can find in the social media lah. Okay, so all this you have to read. Okay, so okay, because of that one, okay, when after that the study that's the light spectrum produced by the experiments, okay, so it proved that so the continuous spectrum it doesn't really occur in that way. So actually occurred in that packets of light. So this came out the idea we call it about the quantum of energy. So we don't see the light the radiation as a continuously radiation. We see as a discrete energy. So discrete energy means that it's a packet energy. So it's not a continuous energy. That's why we came out the line spectrum like this. So it's not continuously spectrum. So each line here is a one packet of energy. So this consists of a wave here. So here is consists of certain wave. So it's not continuously. So each one is a one packet of energy. So this one we call discrete energy. And then the discrete energy, so we call it as particles of light, which is the name as a photon. All right. So this packets of energy we know it as a photon. Photon are the light energy transfer, okay, transfer in the quantums of energy. Okay, and then the calculation about this energy is E equal to SF because the photon energy is directly proportional to the frequencies of light wave. Right, and then to calculate about this quantum energy of light, so with the formula, and then here this hash is a Planck constant. So don't worry, as a constant value, it will provided in the exam, right? So you just need to know that when we want to calculate the light energy, we use this formula. At the same time, when we want to obey the principle of the conservation of energy, so this energy, it can be equal to the other's energy when assuming the energy is converted or energy is transformed, right? So and same time this formula also can be changed because last year we learned already from the speed of light wave, right? C equal to the F lambda. If the speed of light or speed of the wave in the vacuum is the speed of light, so we use a symbol C, which is a 3 times 10 power 8 meter per second. So which is the speed of light in the vacuum. So we change the V equal to F lambda, become the C equal to F lambda. So from here, the frequency will equal to the C over lambda. Then we can substitute into this formula. So you can make it as a, okay, equal to the hash C over lambda. Right? So that is why it given like this one here. Okay. So when the example question here, we're providing the different wavelength. So we're able to substitute the wavelength by multiply the two constant value, Planck constant and the speed of light. So we're able to know their energy. So from here, it proves that the shorter wavelength will have a higher light energy, right? So the higher, longer wavelength will be the lower energy, right? So that's why the E1, the energy is, this one is higher than the E2, okay? So this is a photon energy. Okay, Regarding the wave particle duality, this one, okay, so I will continue for the next class. So for this morning, I stop here first. So what we learned for this morning, first one, make sure that you know what's meant by the black body. And then the second, okay, to understand about this graph, right? So especially on the different temperature, why it prove it with the different names of light, the blue star, white star here. So I hope that you understand. And then from the graph itself also is proving that something against the classical theory. So this is why and how sparking of the quantum theory, right? Okay, and then here's an example on the black body, right? So and then the problem of the diagram A I told you already. Okay, so and then here are the gentlemen that involved in the sparking of the quantum theory, right? So divided to two different parts, classical theory and the quantum theory, right? And after that, we also know what's meant by the quantums of energy. So quantum energy, basically, we see the energy, the spectrum is not the continuous spectrum. It becomes the packets of energy. So this packet of energy, right? So it's not the continuous energy. So therefore, based on the certain specific wavelength, we able to know, right, what is their energy, because we see now the energy as a packet. So it's not the continuously energy, right? So that's why we can substitute with a specific wavelength to finding this photon energy. And then the formula here is given, and then involve the Planck constant here. So later on, we will learn how to define this Planck constant. The Planck constant actually is not really important. So next class, I will explain about the more further discuss about this Planck constant later on the next class. Okay. So and then the formula we can transform, okay, by substitution the frequency related to the wave speed formula. So that's why we from here we able to know the photon energy by the certain different wavelength. So same as given the example one here. So far, not much thing we learned this morning. So okay, you just have to understand all these things listed, and then they got no further explanation needed for the syllabus because we learn with the surface. So just basically it's what you did, what you answer the question, right? So and then we continue the next class. So I will inform in the class later, right? So that's all for this morning. Okay, thank you to follow the class. All right, see you later. Bye.
Thank you, teacher. Thank you, Miss Ang.
Thank you, Joe.